So here's a typical trap. I use the term crown weir. So it's this water that's sitting in this U-shaped part that's going to keep those sewer gases from coming back into the house. If this gets siphoned out or drained out or leaked out, then we're going to be open with air, and that's going to be able to get into the house. Now, there's different ways that we create those siphoning effects. Some of them are rather quick, and some of them take a long time, all right? Here we're showing different types of features or different types of ways to make those traps. I'm not a big fan of gluing a trap and making it permanent. I do like those screw fittings so you can take it off. If somebody does drop something in there and it gets caught at the bottom of that trap, you know, simply unscrewing it, we could go ahead and find it at least. Otherwise, we're cutting pipes, damaging them, and then we have to repair everything when we come back in there. You know, but it's still not the end of the world. I just want my clients to know if it's fixable or not fixable. All right. Sometimes we can use the soil stack as our vent, so we don't have to have an auxiliary. What we don't want to have happen is where our trap comes and it goes back up, and then on the top of that U where I'm going up, I don't want that to continue straight up to be my vent. It's got to make a turn, and as it makes a turn, then we want to go ahead and put the vent. Typically 5 feet is a decent number that we're going to run into for most sinks, all right? I found that if we're within 5 feet of a soil stack, and most of our soil stacks are going to be like right wherever the toilet is, they kind of keep them close to that where the bathrooms are. So if my sink and tub are within that range, I don't have to run a secondary vent or branch vent to it. You may. There's nothing wrong with it. Now, if you're suspicious and you're not sure if they got a vent there one way or another, especially like kitchen sinks by windows, and it looks like that they remodeled everything and just put in a new kitchen sink. This was another one that caught me by surprise, and my client called and they were not happy with it when they figured everything out. Now, it took them 4 plumbers in 2 weeks to be able to figure out that kitchen sink wasn't vented, all right? Whereas I had 15 minutes. So they weren't too mad at me, but they definitely wanted to educate me, and I respected it, I listened, and now it makes me a little bit cautious. So if I have a window over a bathroom, a window over a kitchen sink, and I try to be a little bit more aggressive around those areas. So I fill up the sink with water, I give it a good drain, and I listen for the gurgling effect. If I hear it, I'm going to call it out. If I don't, I'm not. But that's still not a guarantee. Somebody could put an air admittance valve behind a wall. They could have done a whole bunch of stuff that we're not going to be able to see. But if we're too far away, then we're going to create those siphons, and that's where the problems are going to come into play. Double traps, we did see this on one of the houses that we did a field training on, I don't know, about 3 or 4 weeks ago before making this video. And they actually had the shower trapped, and then the shower went into the drain for the sink, which was actually trapped in the basement and not under the sink above. So the shower would trap, and then the sink would trap, and then that would go into the soil. So in a nutshell, even if I got an air brake, so the left sink is that air brake, even if I have that, then these are just still prone to siphoning each other out. So one will keep pushing while the other one's done. I've seen it in one house where we had the double trap, and I swear that gurgling lasted for, I want to say about a minute and a half. You just hear gurgle, stop, gurgle, stop, gurgle, stop. Now in this situation, because we have that sink that's in between there, that would probably stop the gurgling. But if that was filled with water and draining, that would get air being sucked into both of them, especially if the right side was empty. Then that would go ahead and gurgle. This is just a cool picture. You know, hopefully you're going, what the hell is that? You know, and Lord knows I did when I first saw it. This was an 1800s Victorian home in Elgin, Illinois. And there was no way in hell that the owners of this home were going to allow this thing to disappear. This is a mechanical trap on it. It's not vented. It goes straight down into the sewers. The piece that's sticking out kind of like a cone towards us, that's spring loaded. As water gets in there, it pushes that in there, and then water continues to go down. This thing is probably 80 to over 100 years old, all right, as a guess. It's all brass. It's solid. You can see the green. Maybe it's copper because of the green. You can see the green on the pipes. You can see the corrosion on the pipes. You can see the water damage on the floor and the tile and the wood that it's happened. So this thing is leaked. It's been fixed. It's leaked. It's been fixed. You know, obviously it's over 100 years old. I just thought it was cool, and I would agree that there's no way. But I'm still putting it down that my clients should expect it to leak, because I don't want them calling me and complaining if it does leak, and them being able to say that you didn't tell me that this was going to leak. So these are the problematic ones. Things that usually end up causing clogs or causing them to be siphoned out for whatever reason. So starting on the left is a typical S-trap. Older homes, it was just very common. We never worried about venting all the sinks. We just vented the system when it came out to it, or the main soil pipes that came in there. But an S-trap, you can see how it goes down, up, and down. If I get enough of a water flow, that can create a siphon. And if I pull everything out of the bottom trap, then I'm going to let soil gases come into the house. Solution, turn the water on slowly and fill it back up again for a few seconds, and there won't be any smell. The middle one is what we call a crown vented trap. I kind of talked a little bit about this before, but now you're seeing a diagram of it. So the sink comes in from the right, goes down, and the vent goes straight up. We don't want that. We want it to go up more like the letter P and go to the left for a foot or 2 or 3. And then we want to get our vent in there so we can let that water get filled up, and then we can break the siphon. Drum traps, they're still putting them in today. I don't know what much more to say. I can't stand these things, plain and simple. I remember my first house in Elmhurst, we had a drum trap in there, and I still have nightmares over this thing. My tub clogged up. And realize I was a 24-year-old kid. I didn't know anything about plumbing at the time. So don't judge me for what I'm about to tell you. I'm just being honest, all right? And I had my bathtub. It was not draining right. It was clogging. And I didn't know anything more of it. So I went and I got one of those handheld rodders, that you crank from the Home Depot store. And for those of you that know what's going to happen already, you're laughing at me, and I don't blame you. You're like, oh, that's bad, and you're right. Oh, it's bad, So I put that in the pipe, and then all of a sudden it tied up in knots inside that drum trap, and I couldn't get it out again, So now it's stuck in there, and I'm like, again, a few colorful metaphors came out of there. So then I went around the closet, and in the closet was a piece of plywood, which was my access panel, and I opened that up, and I see the drum trap on there. Well, then the drum trap has a brass cap on it, right? And again, I was young, naive. I didn't know better, all right? So I go get a pipe wrench, and I try to unscrew this thing and get it off to see what's going on inside of it so I can figure out what the problem is and fix it. And it wouldn't budge, right? So what do? You go get a bigger wrench. So I went and I got a bigger wrench, and I pulled harder, and it still wouldn't budge, right? And I'm about an hour into this thing. I'm hitting it with hammers. I'm pulling on this thing. I'm giving it everything I got. Nothing would happen. So, I'm a smart guy for a 20-something-year-old. And I think I was still like a teenager. So then I said, well, let's get some leverage. So I had an old fence post outside. I grabbed that, slid that sleeve over the adjustable wrench, or the pipe wrench, and I got way out there and I got that leverage and I pulled hard, and all of a sudden the nut snapped off on me, right? And then I'm like, holy crap, now what do I do? I didn't figure it out. So then I'm like, I got to get that off of there. So I took a chisel and I started hammering away, breaking it away. And shorten up the long story that there's no way I can get it any shorter than what I was just doing. I go to the store, buy a new one, and I find out that they were like $1.50 or $2. And I could have easily have taken a Sawzall and just cut that damn thing and broke it in there and pulled everything out of there. And I would have saved myself about 4 hours of trying to pry that thing off. And every time I run into these things now, I would never try to get it off. I mean, I get it, but I try to break that nut right away and then Sawzall the cap and get rid of it. Then I had to cut the rotting machine, clear out all the goop that was in there, and then we had good water flow coming in there until it gooped up again. So, sorry, didn't mean to bore you with that story. Hopefully you're laughing at me, but life goes on and I learn from my mistakes. This was in that same house that we saw the mechanical trap. Obviously, they've updated some of the plumbing, so you can see the cast iron going out to the street, and then we have a PVC pipe going up and to the left on there. They also had a building trap that I thought was interesting. Typically, we don't see that. We let those pipes, be a straight run all the way through the roof, so that if any sewer gases do come up there, we let them vent out through the roof. But the building trap in here prevented that, at least on that line. Obviously, the one that's coming to the right of it, and they did merge together. Sewer gases would still come up there. But it was kind of a no-brainer, when somebody puts duct tape around a pipe and a bucket underneath there that has water in it, there was a pretty good chance that it's leaking, and this one obviously was leaking when we came with it. Backflow valves, this drawing, and I think the picture on the next slide, are from areas of warmer climates, all right? So, and I'm not an expert in Arizona or Texas and stuff like that, but I don't believe they go as deep with their sewer lines as we do, all right? I think there's someone on the shallow run, so it's easier for them to fix things if they can get to them. But even with water or waste lines, there's been I want to say it was like the 70s or 80s, we had a whole bunch of flooding up in this area. And a lot of plumbing companies, when the sewers would back up into the houses, they would sell these backflow prevention things. Some people actually put big gate valves into them, and some people just had flapper valves that came up. Sometimes they went down, sometimes they went up, whatever. So the water would flow one way, and then if it was flowing backwards, the valve would close and stop it from coming up, all right? This is an actual one where you see it in the ground. Water's supposed to go in there. This one's hanging down from the top, so it prevents the water from going backwards and coming back into a house. Direct venting, I made that mention before. If we're within 5 feet, typically we're not going to have too much of a problem with it. Anytime you're suspicious of it, though, you should fill up the sink and give it a good drain and see if there's any sort of problems. You don't always know what's going to be behind the walls. I know there's more and more tools that are coming out there. I think there's this like Wallabot or something like that that attaches to your iPhone, and it's able to identify things that are behind the walls. I've heard people play with them. I've seen videos with them. They look pretty cool, but I don't own one, and I really can't verify for sure. So whether or not we're properly vented, air vented, branch vented, air admittance valve, we don't know, all right? So we need to make sure that our clients are aware that anything that is behind the walls, we're not going to be able to tell them anything about it. It may seem common sense to you. It definitely seems common sense to me, but you would be surprised on your client's expectations on what they expect you to know, what they expect you to do, and they expect you to tell you. And if they think you're wrong, it's very difficult to get that back. You almost have to get into an argument with somebody about those expectations and let them know why it's right and what it's for. All right. This was kind of one of my favorite pictures that we took at one of our field training houses, and that they put, what is this, 1, 2, looks like 3 extensions. So I got 3 extensions on there, and it's still too long. So it's kind of like my old joke with the board. I cut it 4 times, and it's still too short. All right, causes of broken trap seals. Most common cause we're going to run into would be a negative pressure or aspiration. So here they're showing a large flow of water from the toilet. We're not vented properly with the sink or the laundry tub or something else that's nearby. That's going to create a negative pressure and siphon out that water in the trap. Once the water's gone, then air is going to be able to come back up. All right. Next one is going to be gravity and speed that comes in here, or momentum, as it says in the upper right corner. Typically, we don't want to go more than 2 feet. I think the max, I want to say, is 30 inches. It might be 36. I'd have to look that up in the code books again to come with it. But 2 feet is going to be a magic number. So if you ever have a trap that's below the floor from an appliance above, I mean, if it's a shower and it's right up there, typically not too much of a problem. If it's a sink that's coming all the way down and putting the trap in there, you're going to be at least 2 feet at that point in time, and you're going to start having, some sort of issues coming in there. Laundry tubs, it happens, or laundry drains, it happens with them quite a bit. They're a little bit higher. So you might be at that 3-foot spot. The only way you're going to know something like that is happening is going to be sewer smells coming in there. And they're really, other than filling up a sink, there isn't a good way to do it. So just momentum, speed, or go ahead and do it. Hair is a huge one, especially if you don't use that appliance for a while. So if you get hair that's caught in the drains, and it doesn't necessarily have to be in the trap. It could be anywhere down the line. But that acts as a wick, and it'll just keep sucking the water right out of there, just like a lantern would lift the oil out of there, and it would just move it right over. Typically, you find this happening in vacant homes. Sometimes people think that it's because the water that was in there evaporated. It may be. It's hard to tell. But if you end up, when water in trap evaporates, if you tell them to go ahead and put vegetable oil or some sort of oil in there, that tends not to evaporate as fast as the water does. But if there's hair in there and that hair is pulling it up, that'll actually siphon out faster. So if you put the oil in there and the smells come back, chances are it needs to be rotted, jetted, whatever. Or if it's pieces that are replaceable, replace them. Something if you're going to leave it vacant for a long time. If it gets used a lot, it really doesn't come into play. S-traps, we kind of talked about that before. They create that siphon or that momentum. And if we get all the water out of there, then sewer gases are going to come back in here. Loop vents. These are for island sinks. There's a few different methods, and this is the most common. And this is what pretty much what the state of Illinois and all the communities around us want them to do. They get that loop up as high as possible because you're not going to be able to get past that island. And you're not going to be able to get past that island to go ahead and send a vent stack up. Sometimes people will cheat a little bit and they'll sneak an air admittance valve up on there. So when you're looking underneath the sink, we really should be seeing a couple different pipes there. They may have one visible and one not visible. But if one does go up, do your best to get your phone or your camera, get that back in there, and then take a picture of the underside and just make sure we don't have an air admittance valve stuck in there and trying to shortcut. Those air admittance valves, and I'll show those in a little bit, they're kind of like an anti-siphon device, only, they're just designed to open up quicker and easier. They do fail, and if they fail in the open position, then we're going to end up getting sewer gases coming into the house. If they fail in the closed position, then we're going to end up siphoning out our traps and, again, getting sewer gases coming into the house. This is another way to do it, and it's really not acceptable in our area, but from what I understand, it does work. I have seen it. I have tested it. I have not been able to make it siphon out. So what we're looking at here is a sink and an island. We put our trap, we start off at 1.5 inches. And then every time we make a turn or every time we go a certain distance, if you notice the pipe keeps getting bigger and bigger and bigger. So we go from 1.5 inches to a 2 inch to a 2.5 until we get to the soil stack. And as long as that pipe keeps getting bigger and bigger, we're not going to be able to fill that pipe up completely with water. So there's going to end up being air and water in that pipe. As long as we have air and water in that pipe, we're not going to be able to create a siphon. You know, the air will flow one way and the water will flow the other. This is what an air admittance valve looks like. You know, so whenever there's gas pressure or something coming in there and smells, it's going to force everything shut so that those smells can't escape. But as water is running and it creates a negative pressure inside the pipe, that cap is going to lift up and then it's going to allow air to enter. So we're going to break up the siphon. You know, and again, it's just pieces of plastic or whatever. Some of them are spring loaded. They're sliding on top of each other. Moisture is going to be there. Corrosion is going to happen. Eventually, they're going to be stuck in either the open or closed position. There's not a lot of pressure to move these things. All right. If we do put it on there, it does need to be above the flood rim anyway. Or I'm sorry, here they're saying the trap arm. But truthfully, you got to get above that water line up in there. Because if you fill that sink up, and let's say I have a little bit of a clog and it's not draining fast, that water is going to seek its own level and it's going to push right up that air admittance valve. And the water is going to end up coming out of there and they're going to end up leaking too. So the higher the better. Vent sizes when we come up through the roof. Typically we don't want to see these 1.5 inch pipes or 2 inch pipes coming out through the roof line. They should be expanded to be about 3 inches. The only time you're going to see a narrow one is going to be a pre-World War II home. And it'll be for the kitchen sink area only. So it's just a waste vent or an air vent for a waste pipe. So there's only water that's going in there. The problem with that, and especially because there's always going to be humidity and moisture in those pipes. And if I'm above the attic and I'm not heated anymore, that humidity, that moisture that's going up there, and that's natural, it's going to keep flowing up, that's going to freeze. And when that freezes, it makes these big snowflakes and it expands real fast when it freezes. That frost is actually called, has a specific name to it, and I'd like you to remember that name. It's called hoarfrost, H-O-A-R. And that hoarfrost, if it keeps going, it's actually going to seal up that vent, and we're not going to let the air flow anymore. And if we don't let the air flow and we're not vented, then we're going to start siphoning. That air is going to come into those pipes. It's going to come in from somewhere. If it can't come in from the roof, it's going to come from our traps that are in our plumbing pipes, and we're going to siphon those out, and again, sewer gas is going to start entering our building. Common sense stuff, you know, we don't want to put a soil stack next to a window. This happened to be in Elgin as well. We were doing field training out there, and this was not the house that we were inspecting. This was actually the neighbor's house, and down below they put that addition on, and they put a bathroom in the addition, and instead of going to the left or the right of that window, they just went above the roof line and stopped it right there, and that would be it. And, I mean, common sense, you know, somebody uses that toilet, you're going to have smells come out of there. If anybody has that window open, the smells are going to come back in the house. And we could giggle about it, and I get it, I would too. But in all reality, it's not healthy. You don't want those sewer smells coming in here. So there are some numbers. If you are taking notes, and I hope you are, these numbers that are written here in that box are important. You definitely want to get those written down. So 3 feet above a window, 12 feet from doors and windows, if it's on the same level. All right. 6 feet from the property line, 7 feet above a deck, and 7 feet above the ground. All right. So if I have a deck on this roof, it has to be 7 feet higher. I see that a lot in Chicago. I mean, a lot in Chicago. People put these rooftop decks on, and the plumbing pipes go up there, and they just build right around the plumbing pipe and they leave that small pipe there. They don't extend it to be 7 feet higher than their walking surface. And I guess if you're outside and you know what's there, you're going to live with it. But yeah, living with the smells, they're used to it, and it's no big deal. But realize it's not just when somebody uses a toilet. That pipe goes straight to the main sewer line. So it's not just this house, it's every house in the neighborhood. Whatever sewer smells are in that main sewer line are going to come up everybody's vent stack. And if that's someplace where you're sitting and you could breathe it, again, I think it's unhealthy. And we should be extending these up higher. All right.